Hey guys, so we're going to get started on the second to last video that you guys are going to have for this chapter. So section 7.5 uses proportional relationships in real world examples actually. So you guys are always saying, when are we going to use this in real life? And it's nice because this section actually kind of helps you do it. So the first thing we have to talk about is indirect measurement. So this allows you to find distances that cannot be measured directly. And it uses similar figures and proportions to measure an object. So this is done mainly with scale drawings, which you guys have, I'm sure, seen before. But this represents an object as smaller or larger than its actual size. The scales drawing is the ratio of any length in the drawing to the corresponding actual length. So in this example, if we were to look at a map with a scale of 1 centimeter to 1,500 meters, 1 centimeter on the map represents 1,500 meters in an actual distance. So when you look at Google Maps and you're looking at the route that you're going to drive, obviously that's not the true distance on your screen, it's a scale drawing. Cool? So before we can do this, we got to look at some stuff that you probably did in science class. Centimeters are broken down into millimeters, which I'm sure you guys have dealt with before. And it's nice because 1 centimeter is equal to 10 millimeters. With meters, everything's broken down into tens and sets of 10, right? So 1 meter is actually 100 centimeters because that prefix centi means 100, like a century, right? Inches, unfortunately, don't break up so nicely. Inches break down into sixteenths. So a lot of times trying to use feet and inches in the same problem can get really weird. 1 foot is equal to 12 inches, so those don't even match. It's really hard to sometimes use both of them. So we're actually going to talk about how to convert from feet to inches and inches to feet. So let's look at these two examples down here. If I want to take 6 feet 3 inches and convert it strictly to inches, I have to take those 6 feet and multiply, because I know that 12 inches, is 1 foot, which means I can get that to 72 inches. And then I had those extra 3 inches. So 6 foot 3 means 75 inches. Cool, that's nice and easy. Take the foot, multiply by 12, add the remaining inches, that's no big deal. Now we're going to do the opposite though. Now we're starting with 80 inches. I need you guys to get your calculators ready because you are going to need them. We're going to take those 80 inches, multiply by 1 foot over 12 inches, which essentially means we're doing 80 divided by 12, excuse me. So if you do that in your calculators, I want you guys all to grab your calculator and do this with me. We get 80 divided by 12, and it's 6.6 repeating feet. But do you ever walk up to somebody and say like, hey, I'm 6.6 feet repeating? Like, no, that doesn't make any sense. So what I want you guys to do is take that whole number, take that 6, and recognize that that's 6 feet. All right, on your calculator, subtract that whole number. And you're left with just the decimal, right? Well, that decimal is a portion of a foot. Multiply it by 12 to get it back to inches. So means that it is 6 feet 8 inches. Cool, so you guys are going to go through this process every time. You divide by 12, subtract the whole number, and multiply the remaining decimal by 12 to get it back to inches so that we've got both. All right, so this first example that we look at actually uses that process. So pretty much this girl's got a giant pineapple and she wants to measure the height of it, right? You guys can read through the problem on your own. I'm not worried about that. But she measures her shadow, the pineapple's shadow, she knows her height, and she's going to use that to find the height of the pineapple because we're going to set up similar triangles here. So let's start by drawing a picture of what's going on. We've got this pineapple. And we're looking for the height of the pineapple, so I'm going to put an X over there. And we are told that the length of the shadow for the pineapple is 8 feet 9 inches. And then we've got a student standing here. The student's shadow is 2 feet, and the student is 5 feet 4 inches tall. We need to figure out the height of the pineapple in feet. But 8 feet 9 inches is not 8.9 feet, you guys. And 5 foot 4 inches is not 8.4 feet. So we want to take those and convert everything into inches so that we can make proportions nicely, and then we'll just end up converting back. So when you look at this 8 foot 9 inches, you're going to do 8 times 12, and that's going to get you to 96. And we're going to add the 9 in there. So we get a total of 105 inches. 2 feet should be nice and easy. Multiply by 12, you'll get 24 inches. And then the 5 foot 4, we're going to do 5 times 12 to get 60. And add the 4, so that's giving us 64 inches. So what I'm going to do is I'm going to draw myself a new picture since I've got a lot going on here so I can see my triangles nicely. So here's my pineapple. It's got a height of I don't know what, and it's got a shadow of 105 inches. And then my girl over here has a height of 64 inches and a shadow of 24 inches. And now we can just set up our proportion, right? The height of the pineapple over the height of the girl is going to be the shadow of the pineapple over the shadow of the girl. And we can cross multiply. So 24x is going to equal 6,720. X is going to equal 280. But remember, it's not 280 feet because we converted everything to inches, right? So don't forget that we now have to convert back. So grab your calculators. We're going to end up dividing 280 divided by 12. And if you do that on your calculators, everybody grab your calculator, do it with me right now, please. 280 divided by 12 gets us 23.3 repeating. So do the same thing we just did. That means it's 23 feet. So I'm going to subtract that 23, and I'm going to take my decimal and multiply by 12. So I'm left with 4 inches. 23 feet, 4 inches. That's a pretty tall pineapple, actually. All right, next one. So Jasmine's trying to find the height of this palm tree that she sees. She takes a mirror and she places it 2.5 meters from the base. She steps back until she can see the top of the palm tree in the mirror. So let's draw a picture of what's going on here. Here's my tree, right? She's trying to find the height of some tree. And on the ground, 2.5 meters from it, she places a mirror. So our mirror is going to be that dot right there. And then she steps back until she can see the tree in the mirror. And she ends up stepping back 1.5 meters. Then it tells us that her eyes are approximately 1.9 meters above the ground. So we've got these two triangles here, right? The cool thing about if you go outside and you place a mirror down on the ground and you look at it, then the angle here and the angle here are actually going to be congruent to each other. All right, so you might learn about it in physics when you take that class, but the angle in and the angle out when you're looking at a mirror and you're doing a situation like this, they're going to be congruent to each other. So these triangles are congruent by angle-angle similarity, which means I can set up a proportion. So the height of my tree and the distance to the mirror from the tree is going to be, oops, that was not what I wanted to do. Ignore me. Let's not do that. How about the height of the tree and the height of the girl, Miss J? Man, you guys, I'm on a roll. The distance from the tree to the mirror and the distance from the girl to the mirror. How about that proportion, Miss J? Cross multiply. 1.5x is going to equal 4.75. And we get x to be 3.2 meters. So the tree is 3.2 meters tall. Cool. These are really kind of the same proportions that we've been setting up. It's just that now they're applying them to some real world situations. All right. So take a look just at the picture for number 5 for me real quick, because the wording is kind of weird. Let's focus just on this picture. And the thing that I want you guys to know is that this right here is a right angle. All right. And this right here is also a right angle. And we are going to use reflexive property to say that angle A is congruent to angle A. That's something that a lot of you keep missing. Anytime you have these overlapping triangles, we have to remember that we can use the reflexive property. So let's take a look at the two triangles that we have. We have ADB. This distance is 40 meters. This one's 320. And then we have the big triangle, which this is the distance that we're looking for, so I'm going to call that X. Well, I should probably label my sides too, right? AEC. Now be careful, because AC is not just this distance of 162 right here, right? AC is this entire thing, so we have to add those together. That's 482 meters. And let's not forget that angle A, we're using reflexive property. So these triangles are similar by angle-angle similarity. And we can set up a proportion and solve. So let's go ahead and do this. 320 is the hypotenuse. Let's just start there. So 320 over the other hypotenuse. Oh, you guys can't see. How about I move over a little bit so that you can. So 320 over the other hypotenuse, which is that 482, is going to equal this perpendicular height, so the 40, over the perpendicular height that we're looking for, that x. And then we just cross multiply. Once you set up your proportion, it's nice and easy. 320x is going to equal 19,280. So x is going to be 60.25. But we're being asked to round to the nearest tenth of a meter. So we're going to go ahead and round that to 60.3 meters. So the distance across the lake in this picture is 60.3. Cool? One more, bear with me, we're almost there. All right, here we are talking about the Lincoln Memorial in Washington, D.C. And we've got a length and a width, and we're given a scale of 1 centimeter to 15 meters. So this is kind of like the problem with the map, right? Or like a blueprint. So I'm going to go over here, and the first thing I'm going to do is I'm going to remind myself that the scale to the actual is simply 1 centimeter to 15 meters. All right, and then I'm going to draw myself a picture of this scale drawing that they're going to have. But I don't know what my length and my width are. They're asking me for them. So for now, I'm just going to call them X and Y. I do, however, know the length and the width of my actual. So this is my scale. This one is the actual. The length of the actual one is 57 meters. And the width of the actual one is 36 meters. Since I'm solving for two different things, the length and the width, I'm going to have to set up two different proportions. So let's find the length first. All right. So I'm going to take my original scale that I was given, 1 over 15. And the 1 is with the scale, which means if I'm looking for the length of my scale, that's the x. And the length of my actual is 57. And then we can just cross multiply. So 15x is equal to 57. Divide that 15 over, and we get x is equal to 3.8. And we have to think about what our units are, right? So we had centimeters over meters, and this distance is meters, which means my x value is going to have to be centimeters. We have to keep that consistent, right? That's my scale drawing, so the 3.8 is centimeters. And then we got one more, right? We have to solve for y. So we're still going to use our original scale, 1 to 15. And now I'm looking for y. I'm looking for the width of my scale drawing, and the width of my actual was 36. Cross multiply and divide it over, and we get y to be 2.4, and again, that one's going to be centimeters also. All right, so again, it's not really any different than some of the stuff we've already done, but I think the hardest part is going to be those feet and inches and converting them back and forth. So we'll do tons of practice, don't worry. If you have any questions, make sure you jotted them down. We'll talk about them in class. I will see you guys later. Bye.